Hi, my name is DatT, and this is my midterm individual technical presentation. As a client, I want to navigate to find the Find Service activity so that I can select which service I need from my vehicle. So for this user story, what I do is I create a navigation, which is using a drawer menu, and then the user can click on the menu item and it will navigate them to the Find Service activity. So here is a sequence diagram. So the user start up with setting the navigation item select listener to listen to the menu being clicked. And then when the user select the Find Service menu item, it will start the activity from the welcome activity with the intent, of course. And then that will start the Find Service activity, and it will run the onCreate function. And then once the users in the Find Service activity, they can hit the back arrow to go back to the welcome activity. So here on back press, when the user, it will run when the user select the back arrow inside the Find Service activity, and that will resume the welcome activity. And since the drawer exists in the welcome activity, they have identical lifeline. And here, the Find Service activity is not created until the user starts the activity, and then the Find Service activity also terminate once the welcome activity is resumed. As a client, I want to select my vehicle from my garage in the drop-down so that I can specify which vehicle needs service. So for this one, the Android default spinner doesn't have a hint, so it's just empty. So what I did was I inherit from the array adapter and then override these three methods to create my own spinner that display a hint on the spinner. So I create a hint spinner adapter, and I inherit from this class, and I override this three method. So it's enable, I use it to disable the item at position 0. And then the get view, I customize it. So if the position is not at 0, then I want the text color to be purple. And also I customize the get drop down view. As you can see in here, I put, if the position is at 0, then just display it as a gray text, and it's also disabled, so you cannot select or click on it. But anything else, position 1 or 2 and so on, the user can click and select on it, and the color is dark black instead. As a client, I want to submit my vehicle issue to the selected mechanic so that they can see my request. So in the request form, we had a form that the user can fill out, but I have this submit button, and I only want this submit button to be enabled and clickable when the form is valid. So this is a state diagram. So what happened is we start out here that the form, the button is disabled first, and when the form is valid, then the button is enabled, which will change color to purple, and it is selectable. Let's say if the user took out the time and the availability or don't select a vehicle, then the form will go back to becoming invalid, then the button will be disabled. As a client, I want the post service request form to auto-populate my vehicles on the drop-down from the database so that the form has my latest vehicle information. So for my vehicle spinner, what I did was this is a observer pattern. So the spinner is listening to the collection on Firestore to see if there's any changes to it. If there's a change on the collection, then the spinner will update. So here I have the spinner, and it's listening to the vehicle's collection. And if any data inside the collection is changed, then it will populate, update on the spinner. So here the spinner is the observer, and and it's subscribed to the collection with the app snapshot listener. So then when the data on the collection changes, the spinner will run the notify dataset change to update the data in the vehicle spinner. As a client, I want the service request to be saved on the database so that the mechanic can receive it. So one of the issues we had in this project was our model was getting big. We trying to store too much attribute or field in our objects. So we had to decompose the object into smaller pieces so that it's easier to handle. And the biggest object that we had was the request object. And so here request, we broke it down to hold the client information, which contain like their address, their the availability from time to time days, and then we also have the mechanic info. Mechanic info will only contain their basic info and the address. So both of client info and mechanic info have address and just their basic information, which is like first name, last name, email, and their phone number. And then in the request, we also have the vehicle that the client selected. So here we split the vehicle out into a separate model. And then we also have the receipt, and the receipt is associated with the request. So at the end, the client can pay. So the receipt contains like information about the payment, tax, or the tips, and the payment method. And then we have the service model. The service model just describes the service that the client selected, and also has the mechanic information that comes with it. The reason why we have mechanic information here and also in the request is because this service model is associated with Algolia. So that's why we need it in here. As a client, I want the search result to display relevant services to my text query so that I will receive appropriate services. So for this user story, we had to, we wanted the search to be fast. So we looked for third-party API that we can use. So one of it was Algolia. Algolia offer like instant search, but the problem is we had to sync the file store data with Algolia, and we didn't want to write like our the server backend to do that. So we use cloud function to handle that work. So what happened is when the mechanic add a service or delete or update to the Firestore, it will send a trigger or an event to the cloud function, and the cloud function will listen to that event. So let's say if the mechanic add a service, it will trigger the onCreate function, and that function will then send the information to Algolia to save the document that was created into a index. And then if the user delete, it will also send the information to Algolia and tell Algolia to delete that index. And then if the document was updated, then the cloud function will tell Algolia to update the index. And then once everything is on Algolia, from the client side, on their app, when they search for a service, they do a HTTP request in the back behind the scene, and Algolia will return a JSON. That JSON data that is filtered only contain services that are related to the query. And of course, on the Firestore, whenever the user do a set delete update, it will also return whether that was success or fail. So that's it for my midterm individual technical presentation. Thank you for listening.